Welcome to the Mall City Mechanical Training Series. Today you will learn about Lockout Tagout, or LOTO, safety procedures. We will strive to provide information that will increase your knowledge and help to make you a better and safer operator. Machines and equipment cannot last forever. So when they break down or are in need of maintenance, proper procedures must be carefully followed to isolate the machine from its source of energy in order to prevent an accident from occurring. This training will outline the measures for controlling hazardous energies. The following is a list of the OSHA's preliminary top 10 most frequently cited standards for 2015. OSHA publishes the list as a means of alerting the industry about these commonly cited standards. The hope then is that you take whatever steps necessary to both find and fix recognized hazards before they become a problem. First and foremost, safety starts with a knowledge and basic understanding of the standards governing your specific industry and work situation. These are some of the main LOTO standards, but it is your responsibility to be familiar with and heed all standards specific to your industry, state, city, and company. Did you know 29 CFR 1910.147 specifies that a worker must take a refresher course if any of the following apply: before the employee is assigned any new duties, there's a change in assigned duties, there's a change in machinery, equipment, or processes that present a new hazard, when there's a change in energy control procedures, when the employer believes that they have inadequacy regarding the knowledge of procedures. With this in mind, in line with OSHA requirements, anyone working in or around where LOTO programs are in use must receive awareness and hazardous energy training. OSHA requires for refresher training are also very specific, as noted above. Initial training, as well as any evaluations or refresher courses, must be documented with the name of the person or persons who taught the class or conducted the evaluation. Although OSHA doesn't require wallet cards as proof of training, many companies and work sites do require on-site proof that you have been trained. At the very least, in the case of an investigation, OSHA will want to see proof of proper and consistent training in the way of training outlines, class lists, training goals, tests, and certificates. There are two primary types of systems used to isolate a machine from its power source. One is by locking out the source of energy, and the second is by tagging out the source, if a lockout system cannot be achieved. According to the standard, lockout is the placement of a lockout device on an energy isolating device. In accordance with the established procedure, ensuring that the energy isolating device and the equipment being controlled cannot be operated until the lockout device is removed. The lockout procedure is achieved by using a lockout device or any device that uses positive means, such as a lock, blank flanges, and bolted slip blinds, to hold an energy isolating device in a safe position, thereby preventing the energization or machinery or equipment. Tagout is a similar procedure. It is defined as the placement of a tagout device on an energy isolating device or piece of equipment in accordance with an established procedure to indicate that the equipment being controlled must not be operated until the tagout device is removed by an authorized person. The tag should be legible and in plain sight so that workers know that the machine is not to be used until further notice. An energy isolating device is defined as a mechanical device that physically presents or prevents the transmission or release of energy, including but not limited to the following: a manually operated electrical circuit breaker, a disconnect switch, a manually operated switch by which the conductors of a circuit can be disconnected from all ungrounded supply conductors, a line valve, a block, or any similar device used to block or isolate energy. Push buttons, selector switches, and other control circuit type devices are not energy isolating devices. More plainly, the energy isolation device is the device that physically prevents energy from being placed into the machine while it is not in operation. To be safe, it is always best to use both a lockout and tagout device whenever possible. This will provide the secure physical protection of the lock, as well as a visual warning that the device is temporarily not operable. A tag alone will never provide the physical protection of a lock, and a lock will never be as eye-catching and informative as a tag. Lockout versus tagout. As noted previously, when an energy isolating device is not capable of being locked out, the employer can use a tagout system alone. But if the energy isolation device is capable of being locked, a lockout device and system must be utilized. Having said that, there are certain general industry service and maintenance situations in which the standard does not apply. We will explain these possible exemptions in the following slides. The first situation which might be exempt from the standard is if exposure to hazardous energy is controlled completely by unplugging the equipment from an electrical outlet. If the employee doing the service or maintenance has exclusive control of the plug. More specifically, exclusive control refers to instances in which the plug is physically in the possession of the employee or in arm's reach and in the line of sight of the employee, or which the employee has affixed a locked tagout device to the plug. This applies only if electricity is the only form of hazardous energy to which employees may be exposed. This exemption encompasses many portable hand tools and some cord and plug connected machinery equipment. A second possible exemption to the standard is if an employee performs hot tap operations on pressurized pipelines. This would distribute gas, steam, water, or petroleum products. In this case, the employer must show the following. Continuity of the service is essential, shutdown of the service is impractical, and that the employee follows documented procedures and uses special equipment that provides proven, effective employee protection. Finally, if the employee is performing minor tool changes or other minor service activities, they might be exempt from the standard. These minor activities must be routine, repetitive, integral to production, and occur during normal production operations. In these cases, employees must have effective alternative protection. In any circumstance, though, your safety should come first. Don't perform any service or maintenance on the machine or equipment until you first understand the proper LOTO procedures and your company has demonstrated full compliance with all lockout tagout procedures. Never operate any energy isolating device when they're locked or tagged out. That compliance with lockout tagout standards prevent an estimated 120 fatalities and 50,000 injuries each year. Equipment. The standard requires that locks, tags, chains, wedges, key blocks, adapter pins, self-locking fasteners, and any other hardware should be provided by the employer for isolating, securing, or blocking machines or equipment from energy sources. In this section, we will go over some of the different types of devices available for lockout tagout, as well as the requirements they must meet. To start, let's look at what is required. Lockout tagout devices must be durable, substantial, identifiable, standardized. Durability. Both lockout and tagout devices must be capable of withstanding the environment to which they are exposed and for the duration of time needed in that environment. Exposure to light, corrosive environments, extreme weather conditions, or wet and damp locations should not cause the tag to deteriorate or the message on the tag to become illegible. In cases where such deterioration is noted, you should replace immediately. Substantial. Tagout devices should be significant enough to prevent inadvertent or accidental removal. More specifically, they should have a minimum unlocking strength of no less than 50 pounds. The standards also say they should be attachable by hand, self-locking, non-releasable, and non-reusable. Lockout devices, too, should be substantial enough to prevent removal, except with the use of excessive force or unusual techniques, such as with the use of bolt cutters or other metal cutting tools. Never, however, remove a tag or device without the appropriate authorization. Identifiable. Both lockout devices and tagout devices should indicate the identity of the employee applying the device. Remember that only the authorized employee can perform the actual lockout tagout, and only they can remove it. Standardized. Lastly, lockout and tagout devices within a facility must also be consistent in at least one of the following areas: color, shape, or size. Additionally, in the case of tagout devices, the format and even prints should be the same. For the energy control program to be effective, all LOTO devices must convey this one message: do not use the equipment when the device is affixed to it. Toolboxes, doors, lockers, out-of-service machines, or cabinets should only receive a non-lockable padlock. Use of a lockout or tagout device on anything other than what is it specified for can lead to confusion, disregard for the control program, and potential injury or fatalities. And don't just use tags if a lockout is required. Tags alone may evoke a false sense of security. Many accidents have occurred from ignoring or bypassing tags. More specifically, when a tag is attached to an energy isolating means, it is not to be removed without authorization of the authorized person responsible for it, and it is never to be bypassed or ignored. Types of LOTO devices. In this section, we will go into more detail about the various types of lockout/tagout devices. Be aware, though, that some machines have more than one source of energy, so you may need to use different energy isolating devices for the different kinds of energy. Make sure that you coordinate with other safety procedures or personnel until all hazardous energy sources have been controlled. Circuit breaker lockout. The first type of device we will discuss is a circuit breaker lockout device. Circuit breaker locks allow a given breaker within a breaker box to be locked in the off position without having to lock out the entire box. Most devices can accumulate single or multiple pole circuit breakers. How to apply a circuit breaker lock. First, move the breaker to the off position. Open the red handle. Place the lockout over the breaker toggle and turn the black knob clockwise until it grips touch the toggle. Close the handle to tighten the grips against the toggle. Move the handle to the closed position and check the lockout is secure to the breaker and not loose. Also, check that the breaker can't be moved to the on position. Finally, apply the lock-in and tag and communicate with all affected employees. Valve lockout. The valve lockout is used to block or prevent fluid and gas valves from being opened during work. Valve lockout devices are used to shut off numerous kinds of pressure valves, including ball valves, butterfly valves, gate valves, and cylinder valves. First, begin by selecting the proper size cover for the specific valve handle. Note: choose a size that is loose enough when applied that doesn't bind the valve handle. Rotate the lockout cover to completely surround the valve handle. Secure the lockout device with a lock and place a tag to communicate any details for the valve lockout. Communicate with all affected employees. Plug lockout. Electrical plug lockout devices are designed to fit over and fully encompass the end of an electrical cord. Varying designs are made to fit cords with ground prongs or end with a wide base. The cord is inserted into the open case, which is then closed and locked with a lock and key, thus preventing access to the plug. How to apply a plug lock. First, begin placing the lockout device directly to the electrical plug. This will push out the eyelet where the lock will be placed. Place the lock with the tag to inform others of the details for locking out the plug. Communicate with all affected employees. Pneumatic hose lockout. These devices are crucial for de-energizing and isolating compressed air sources. The device will fit over the male fitting of a pneumatic hose to deny access to the airline regulator and is then locked in place, preventing any pneumatic or air-filled connections. Open the lockout device and place the pneumatic hose in the correct hole size. Close the lockout device and place a lock with the tag to inform others of the details for the lockout. Inform all the affected employees. Wall switch lockout. This device should be used anytime a wall switch controls the power for a piece of equipment. After flipping the switch to the off position, the device is applied. Two forms of wall lockouts are used most often: a screw removal or screw tightening. To apply this type of device, remove the faceplate screws. Slide the device in place as shown here. Then tighten the screws back into the faceplate. This will secure the device. For additional security, you should then lock and tag the wall device as shown. Group lock boxes are used when there's a need to lock out a very large piece of equipment, one that usually has multiple functions affecting the service being performed. Each lockout point is secured with a lock, and then accompanying keys are placed inside the box. Each authorized employee then places their own personal lock on the box, ensuring the box cannot be opened and the machine re-energized until each authorized person has removed the lock. HASP lockouts. Similarly, a HASP lockout device allows for more than one lock. After the appropriate energy source is de-energized, a HASP is put in place, locking the part out. Each authorized employee or group may then place their personal locks on the HASP. The HASP may not be removed until all groups or employees have finished their work on the machine, and all employee locks are removed. This prevents accidental startup if one group finishes their work ahead of another. With all that in mind, are these good or bad examples of locking out and tagging out equipment? Operations and communication. Now that we have a better understanding of lockout, tagout devices and how to apply them, we will spend some time focusing on basic safe operating guidelines and responsibilities as they relate to the energy control program. Understanding these procedures is essential to maintaining a safe working environment. Energy types. Before we get into the control program though, It is important to first understand the various types of energy you may encounter during LOTO procedures. These main types include electrical, mechanical, hydraulic, pneumatic, chemical, and thermal. All of these energy types can be considered either primary or residual energy sources. A primary energy source is the main supply of power used to perform work. On the other hand, residual or stored energy is energy with the system that is not being used. In many cases, this buildup energy remains ready for use even after a machine has been turned off. To better understand residual energy, think of pressurized water in a hose that shoots from a nozzle until it is gone, even though the water source has turned off. Not properly anticipating, assessing, and dissipating stored energy is one of the most common causes for workplace accidents involving hazardous energy. Electrical. Let's take a closer look at these different energy types. Electricity is the most common form of energy used in workplaces. It is available live through power lines and wires. It is extremely dangerous and should only be handled with training and care. Typically, it can be cut off with the flip of a switch. However, as noted, it can also be stored, for example, in batteries or capacitors. Mechanical. This is the energy exists in components under tension. For instance, a spring that is compressed or coiled has stored energy, which is released when the spring expands. The release of mechanical energy may result in an individual being cut, struck, or crushed by the object. Hydraulic. Hydraulic energy is stored within hoses in the form of pressurized liquid. Under the intense pressure, the fluid can be used to move or stabilize heavy objects, machinery, or equipment. Examples include automotive cars, lifts, injection molding machines, power presses, cranes and forklifts, and even the braking system in cars. When hydraulic energy is released in an uncontrolled manner, it can be extremely dangerous. A leak the size of a pinhole can easily cut through skin and inject itself into the bloodstream. Pneumatic. Pneumatic energy consists of energy stored in pressurized air. Like hydraulic energy, when under pressure, it can be used to power equipment and move heavy objects. And examples include compressed gases, spraying devices, and power washers. When pneumatic energy is released in an uncontrolled manner, it too can be extremely dangerous, even deadly. Chemical. Chemical energy is the energy released when a substance undergoes a chemical reaction. This energy is normally released as heat, but can manifest itself into other forms. A common result of a hazardous chemical reaction is a fire or explosion, which can easily cause serious burns. Thermal. Lastly, thermal energy is energy that comes from heat. This heat is generated by the movement of tiny particles within an object. The faster these particles move, the more heat gets generated. Burns ranging from first to third degree can easily occur. Energy control program. Any energy type you may encounter in the workplace should be outlined in your company's energy control program. According to federal standards, this program must also clearly address the following: energy control procedures, employee training, periodic inspections. The purpose of this program is to prevent injury whenever performing maintenance on equipment that could unexpectedly start up or release stored energy. Employee training. Let's start with the training aspect. Training is crucial in order to keep you and those around you safe. This section of the energy control program should include all the company policies regarding training and retraining employees. It should also clearly explain the three major types of employees described in the standard, namely authorized, affected, and other. Authorized employees. Authorized employees are any employees assigned to service the machinery in question. Consequently, they are too in charge of applying, using, and removing lockout-tagout devices. Furthermore, they must receive training on the recognition of hazardous energy sources, the type and magnitude of the energy available in the workplace, and the methods and means necessary for energy isolation and control. Affected employees. Affected employees consist of any employees affected by maintenance and lockout-tagout procedures. More specifically, regardless of whether you are typically assigned to work on a machine that is being serviced or you work in the vicinity of a machine that is locked out, you are considered affected. These employees need to be able to recognize lockout-tagout controls that have been implemented, understand the purpose and importance of them, and follow all guidelines regarding their use. Other employees. Lastly, other employees, anyone who may be assigned to work in an area where lockout-tagout may be utilized, must also be instructed about the procedures relating to lockout-tagout. Periodic inspections. The energy control program is only as good as it is implemented. To ensure correct energy control procedures are both understood and being followed by employees, the employer must oversee a periodic inspection at least annually. An authorized employee not involved in the energy control procedures being inspected must be the one to conduct the inspection and certify the procedures. The certification should include the following: identification of the machine and devices involved in the lockout-tagout process, date of inspection, name of employees included in the inspection, the name of the person performing the inspection. And where tagout is used, the inspector must again meet with both authorized and affected employees. This review should likewise cover their responsibilities, limitations, and training requirements. The energy control program should be customized to fit specific company policies and situations, all while adhering to federal and state regulations. It must also state the means by which compliance will be enforced. All employees need to be familiar with the content of the program, and the procedures for a specific type of machine should be posted on the equipment where possible or readily available so it can be accessed by employees at any given time. Lockout-tagout process. Let's take a closer look at some of those minimum requirements, namely employee notification, equipment shutdown, isolation verification, device application, shift changes, and equipment startup. Some of these often run together as if they were one and the same, but it is important you recognize them as separate steps, each requiring specific attention. Shutdown. Shutdown is a little more complex than just hitting an off switch or pulling a plug. In fact, proper equipment shutdown starts with planning and preparation. More specifically, before a machine is turned off, the authorized employee needs to have an understanding of the types, sources, and magnitude of energy involved. It is more than just electricity. This knowledge can be found by referring to lockout-tagout procedures and operator manuals, which, in turn, will provide information about common hazards and how to safely control the energy sources. Notification of employees. Once you have a clear understanding of what the shutdown procedures will entail, you need to communicate the plan to others. Communication is essential and is most often the difference between accidents and safety. The more familiar everyone is with the lockout-tagout procedures, the easier it will be for them to identify and communicate potentially hazardous situations before accidents occur. With this in mind, if you're responsible for shutting down equipment, you must notify all affected employees that specific pieces of machinery are scheduled for service before they are shut down. As far as it affects them, they must know the details and extent of the scheduled maintenance, as well as any limitations imposed upon them or their work area during that time. Isolation. Once everyone has been properly notified and accordingly removed from using any machine scheduled or shut down, you're ready to shut the equipment down and isolate all sources of energy transmission. That means all switches, plugs, valves, circuit breakers, and the like. If the equipment has more than one avenue through which energy can be released, they all need to be isolated. For instance, regarding electrical powered equipment, never rely solely on the off switch or plug. Take action at the breaker that feeds the machine too. On that note, there needs to be order in all things. So, while it seems simple enough, make sure to always turn the machine off before disconnecting it at the breaker in order to avoid damaging the equipment. Device application. Applying LOTO devices goes hand in hand with isolating their energy. The standards require that these devices must be affixed by an authorized employee to each and every energy source. Locks must be affixed in a manner that will hold the energy isolating devices in a safe or off position. Where Tagout devices are used, they too must be affixed in a manner that will clearly indicate the operation or removing any isolating device is strictly prohibited. If for some reason the tag cannot be directly affixed to the energy isolating device, the tag must be located as close as safely possible to the device, in a position that will be immediately obvious to anyone attempting to operate the device. As noted previously regarding LOTO devices, there also needs to be consistency. All LOTO devices must also be filled out properly and by the appropriate person, and the information on them must be legible, so there's no mistaking their intent. Never fill out and sign a tag on behalf of someone else. When locking and tagging out equipment, following the same patterns every single time will prevent miscommunication. For instance, take a look at this image. While this has been staged for the purpose of the training, it is something we've come across on occasion. At first glance, it seems nothing's terribly wrong here. The message is certainly clear enough. Do not operate. But that's the problem. By using more tags on this particular device, it seems to say that this is more important than those devices with only one tag affixed. Might then an employee justify removing the tag from a machine with only one, assuming it is not as vital as that they do not operate it? Having said that, no matter the type or quantity of tags, every employee is required to comply with the restrictions and limitations imposed upon them during a lockout. All employees, upon observing a machine or piece of equipment that is locked out, must never attempt to remove the tag or use that equipment. Verification of isolation. Never assume you've successfully isolated all the energy sources for a particular machine without verifying this to be true. The need for verification is often ignored and has just as often led to accidents or near accidents. So before any work maintenance begins, an authorized employee must verify the machine or equipment has been properly isolated and de-energized. To do this, first make sure no personnel are on or by the equipment. Then verify the isolation by attempting to turn the machine off. It should not start. In some cases, machines store energy like hydraulic systems, springs, or pressurized gases, water, steam, and air. Make sure to release all stored energy from performing maintenance, and don't forget to return the controls back to neutral or off position after verification. 2 or more workers. When you verified that the energy has indeed been isolated, you're ready to begin servicing the equipment. But what if the maintenance needed requires more than one authorized worker? In such cases, the energy control procedures and the subsequent period of maintenance must be well planned and constantly communicated in order to prevent accidents or injuries. No matter what, every authorized worker charged with servicing a machine must have their own lockout equipment, and each worker must place their own personal lockout device on the isolating device on the energy isolating device. This is to prevent accidental startup in case one group finishes their work ahead of another. HASP locks or group lockout tagout boxes are ideal for this. Hazards and case studies. Each year, tens of thousands of workers are injured. Hundreds are killed because lockout tagout standards and procedures are ignored. Statistics have shown that there are certain inherent dangers associated with lockout tagout operations, and most injuries and deaths are due to several basic hazards. In this section, we will discuss some of the more common hazards and show you how to recognize these hazards and avoid or minimize them. Accident number 1. During a lull at a car wash, employee number 1 turned the system off, then entered the tunnel to wash dirt and debris from the floor and side alleys with a high pressurized hose. According to the report, a second employee, not knowing the first employee was in the bay, turned the system back on, then got in his car, intending to drive it through. At some point, the hose employee number 1 was using got caught in the side arm brush, which pulled him to the rotating gears. When another employee thought he heard a scream, he turned off the system again and ran into the tunnel, only to find his coworker and friend with his head against the wall and his feet entangled in the side arm brush. He ran back to the office and called 911. By the time the paramedics arrived, employee number 1 was pronounced dead. Obviously, there were several things that might have prevented this accident. First and foremost, the car wash company did not have a written lockout tagout program. Furthermore, the subsequent investigation discovered that it was common for employees of the car wash to enter while it was on. In this case, the victim turned it off, but failed to lock out the controls and failed to communicate with his intentions with anyone else. Shutting down and locking out equipment on which you intend to do maintenance seems like a simple thing, and yet time and time again, workers consider it a waste of time, convincing themselves that they know the equipment well enough and that they will be careful. They justify bypassing safeguards because it only will take a minute, or because they have done it several times before without incident. This could be, and in this case was, a deadly line of thinking. Machines with moving parts always need to be locked out and tagged out, especially when working involves an entanglement hazard like the hose. In a similar, if not more horrific accident, employee number 1, a 41-year-old man, was assigned to wash out an industrial meat blender as part of his nightly routine maintenance. While inside with the garden hose, the machine was turned back on. He was pulled feet first into the blender. Fellow employees heard a terrible series of screams, and rushed to the machine, but it was too late. He died immediately from blunt force injuries and chopping wounds. As a result, the company was fined for gross negligence regarding a failure to implement and enforce their lockout tagout program. Additionally, a multi-million-dollar lawsuit was brought against them by the victim's family members. Accident number 4. Employee number 1 was a temporary employee assigned to help employee number 2, a full-time employee of a recycling company. They were working on realigning a conveyor belt, a fairly quick task for the experienced worker. So they turned off the machine, locked and tagged it out, and set to work. Once aligned, employee number 1 went to remove the lock and flipped the switch at the main source of the button. He did. Upon returning to the conveyor belt, though, he found employee number 2 caught in the in-running nip point between the conveyor belt and the idler pulley. Employee number 1 attempted to free employee number 2, but by the time EMS arrived, employee number 2 was pronounced dead. It's hard to know where to find fault first. A screwdriver was found near the mangled body. It is believed that employee number 2 was either reaching for the tool or decided to make a last-second adjustment right as the power was turned back on. The fact, though, that the belt started right up tells you that only one energy source had been locked out. Either the plug was left in or the machine left on when the power was shut off at the main breaker. To avoid this very thing, you should always isolate all sources of energy, turn the machine off, remove the plug from the socket, and then turn off the main power source. Finally, and arguably the most importantly, the investigation uncovered one glaring omission that might have saved employee number 2's life. He had not received training of any kind, nor had he been made aware of the company's Lockout Tagout program and procedures. In essence, he was simply told to follow the leader and be careful. But when leaders aren't following the rules, it's an accident waiting to happen.